Alright, so I'm going to try and do my best to put this in simple terms. Here we have this black line runs at 45 degrees. From here to this green line represents 1, or the hypotenuse of 1. So 1 forms a square, and its hypotenuse, or hypotenuses, are in it. It doesn't really count, right? But we go out to 2, that's where these lines are. We get that 45 degree hypotenuse. So down here, 1 is a square. If we're trying to approximate a circle, we add the hypotenuse, or the hypotenuse of 2, or 45 degrees. So our angles are 1 over 1 over 2, or the absolute value of 1 over 2, because we're taking all 4 quadrants of our graph. And then, when we move up to 3, we have 1 over 3, and we have 2 over 3 as angles that we take in all 4 quadrants. So our circle bumps up to here. And this continues for every prime number. They create every new angle approximating a circle. Specifically, every time a new prime number shows up, it doubles how many angles are present in the circle. So from 1 to 2, we got twice as many flat angles. We had 90 and 0 degree angles, and then we had 45 degree angles, and then we go up again, we have our 90 and 0 degree angles, then we also have our 30 and 60 degree angles. And then the next time we go up, we're going to have all of those angles plus our angles that are products of 5 and 3 and 2 and 3 and 1 and 5, and so on and so forth. So to conceptually predict where primes are, we just need to space out all of our 1 unit lines in a circle, figure out the angles we need to connect them, figure out the whole number ratios of that over our largest prime, and we will have found our next prime. It's pretty simple. The other neat thing is there's actually no known theory for an ellipse, or formula for an ellipse, but I think it's buried in here. Because here we're making these sides 1 unit long. But if instead, especially as we go up in size, if we take the absolute value of the hypotenuse that leads to our angle in the y-axis, but not the x-axis, we get a smooshed circle. That needs more figuring, but I think it's there.